Now that we know how to find the slope at one point based on a formula, I'm actually going to apply that to a problem. All right, so this question, I've been given 2x cubed. Sorry for the glare right there, it's kind of hard to see. 2x cubed, and we're going to look at the point c equaling 2. So I've got this point on my sketch over here to kind of visualize what I'm looking for. So I want to find the slope at this point. So I'm going to use the formula that we saw in our last video. The limit as x approaches c of f of x minus f of c all over x minus c. So I'm going to start by substituting in the information that I know. For starters, I know that c is 2. So I'm going to have the limit as x approaches 2 of f of x minus f of 2 all over x minus 2. Okay, we have this f of x. F of x is literally your function, which we have here. So I'm going to make that change. The limit as x approaches 2, f of x is 2x cubed minus f of 2. This means I'm plugging 2 into my function. This is my y value. So I plug 2 in. 2 cubed is 8 times 2 is 16 all over x minus 2. So now we've set this up to find the slope at a point. More specifically, to find the slope at 2. If we were to plug 2 in right now, I'm going to end up seeing 16 minus 16 over 2 minus 2 to get the 0 over 0. That's our indeterminate form, which is telling us we got to do more work. Okay, so I'm going to go ahead and factor here. 2x cubed and 16, they have a 2 in common. So that's going to give me, I'm just going to move up a little bit so we have some more space. That's going to give me x cubed minus 8. And then x cubed minus 8, I can go ahead and factor that to x minus 2 times x squared plus 2x plus 4 all over x minus 2. If you don't remember how to factor this, this is the difference of cubes. We've got that pattern. Take a look at how to factor that. Now I have x minus 2 divided by x minus 2, which is 1. So I'm left with the limit as x approaches 2 of 2 times x squared plus 2x plus 4. So now if I plug 2 in, I have 2 times 4 plus 4 plus 4. So 12 times 2, I have a slope at that point of 24. Okay, so I did the algebra to simplify out the issue, the 0 over 0, that indeterminate form, and I end up getting a slope of 24. Okay, something that's really cool is slope is also known as a derivative. We just found the derivative of 2x cubed at 2. Derivative. We're going to be spending a lot of time on that word. Okay? Another way that I can write this is right here. I could write f prime of 2 equals 24. Again, this is f prime. That is another way, or a way to show this is the derivative of the function f at the point 2. F prime is derivative. Okay? Cool. So what we're going to do real quick, try not to make this a super long video, is I'm going to write the equation of the tangent line when x equals 2. So based off of this little picture, let's just say I'm going to be writing the equation of this line. So we have the formula y minus y1 equals m times x minus x1. I need the slope and a point. Well, from my equation, I found my slope. That's here. That's the slope of the tangent line. The x value is what we were given is 2, and the y value is my f of 2, which is my 16. Okay? So I'm using the slope, 24, and the point, 216. So when I write the equation of this line, I'm going to have y minus 16 equals 24 times x minus 2. I'm going to go ahead and isolate the y, and I'm going to get 24 times x minus 2 plus 16. And here is the equation of my tangent line. We could simplify that down into slope-intercept form, or we could keep it here in our point-slope form. And then the last thing that we talked about in class, if you weren't in class, the normal line is perpendicular to the tangent line. So it would come in and do something like this. Perpendicular hits at 90 degrees. So the normal line is perpendicular to the tangent line, so the only thing that's going to change is the slope. Perpendicular lines have opposite reciprocal slopes. So instead of a slope of 24, I'm going to have a slope of negative 1 over 24. So the equation of my line would then be negative 1 over 24 times x minus 2 plus 16, and this is my normal line. Again, the normal line is just perpendicular to the tangent line, so the slope is opposite reciprocal. Okay, we're diving into derivatives. This function right here helps us find the slope at a point, and that is finding the derivative at that point. Okay, good luck on your homework. Email me if you got questions.